Let's look at parallel and perpendicular lines. Things you need to remember from Algebra 1. First, how to find the slope. The slope is the steepness of the line or rise over run. To find the slope, you can do a couple of different things. You can either, if you have a graph, count rise over run, or you can use the formula y2 minus y1 over x2 minus x1. The letter m is used to represent slope. The y-intercept is the point where your graph, or in this case we're going to be looking specifically at lines, crosses the y-axis. All y-intercepts are written as 0, and then we use the letter b for y-intercept. Put those together and you get slope-intercept form, y equals mx plus b. So let's look at an example, just a practice problem of being able to write the equation of a line in slope-intercept form. We are told that the point A is 6,2 and B is 10, negative 4. So in order to write the equation of the line, we need to know the slope, and we also need to know the y-intercept. Because we don't have a graph, we're not going to be able to physically tell what this is. I guess you could always create a graph, but I would make sure that if you were going to do that, you have graph paper. But we're going to use our formulas. So we're going to start by finding the slope. To find the slope, again, that's rise over run, change in y over change in x. I know I used that a lot last year. y2 minus y1 over x2 minus x1. Make sure you put the y coordinates in the numerator, and the order that you write them doesn't matter. So my y coordinates are 2 and negative 4. So I either can do 2 minus negative 4 or I can do negative 4 minus 2. It doesn't matter as long as you maintain consistency. I'm just going to do 2 minus negative 4. And then for the x coordinates, I've got to keep that consistency. So because I used 2 first for the y coordinate, I need to use 6 first for the x coordinate, and then 10. So 6 minus 10 in the denominator. So 2 minus negative 4 is 6, and 6 minus 10 is negative 4. If I simplify that, that gives me negative 3 over 2 for the slope. Now what we can do is we can use the slope and one of the 2 points. It does not matter which point you choose. I'm just going to use 6,2. That point is going to be x and y. So I'm going to use the equation y equals mx plus b, and I'm going to substitute in the coordinates x and y, the 6 for x and the 2 for y, and the slope that I just found, negative 3 over 2, and I'm going to solve for b because that's the next thing I need to find is my y-intercept. So in for y, I'm going to put 2 because that's the y-coordinate. In for m, I'm going to put negative 3 over 2 because that's the slope we just found. X, I'm going to use 6 because that's the x-coordinate of point A, and then plus b. All right, so I'm going to multiply negative 3 over 2 times 6 over 1, so that would be negative 18 over 2, which is negative 9. And then I just need to get the b by itself, so I'm going to move over that negative 9 by adding it, and that gives me b equals 11. So now we're going to take the slope and the y-intercept, and we're going to put them together into slope-intercept form. And that is going to give us y equals negative 3/2 x plus 11. So now let's talk a little bit more about parallel lines. We talked about parallel lines in the first semester, but it was really in terms of the angles that are formed when lines are parallel, or what do you know when lines are parallel, like corresponding angles or alternate interior angles, those types of things. But now we're looking at parallel lines on the coordinate plane. And so just the definition of parallel means that your lines are on the same plane, but they are never going to cross. You should know the parallel symbol. Looks kind of like 2 L's. It's a different color. That's your parallel symbol. And if they are parallel, that means they have to have the same slope, because the only way they're not going to intersect is if they rise and run the exact same amount. All right, so for example 1, we're trying to use 4 points to determine if line AB is parallel to line CD. So we need to determine the slope of line AB and slope of CD, and then compare them and see if they are the same. So if they're the exact same, they're parallel, and if they're not the same, then they're not parallel. So for AB, we are going to use -2, 3, and 2, 6. Remember that slope is change in y over change in x, or y2 minus y1 over x2 minus x1. And again, it doesn't matter which point you call the first point or the second point. What matters is maintaining consistency. So if I look at my y values, which are 3 and 6, and I decide that I'm going to do 6 minus 3, then in the denominator, I need to do 2 minus -2. So that would be 3 over 4 for that slope. Okay. For CD, let's look at points C and D. If I look at those coordinates and I decide I'm going to do 3 minus 0 for the y's, then in the same exact order would be 3 minus -1, which will be 3 over 4. So now comparing the slopes, both line AB and line CD have a slope of 3 over 4. So that does mean that they are parallel. For example 2, they give us the line y equals 1/2 x plus 7, and we want to determine the equation for the line that is parallel to it, but passes through the point 4, 1. So in order to write the equation, I need to know the slope, and I need to know the y-intercept, because we want to write this equation in y equals mx plus b. So to find the slope, I need to look at the equation that they gave us. The slope of that equation is 1/2. And if we're looking for a parallel line has the same slope, so the slope of the parallel line will also be 1/2. So I can go ahead and fill that in, and now all I need to figure out is the y-intercept, or the b value. To do that, we are going to use the point that they gave us, because a point represents an x value and a y value. So if I think about y equals mx plus b, and I plug in everything I know, I should be able to solve for what I don't know. So y, if I look at that point, the y coordinate is 1, so I'm going to put a 1 in for the y coordinate. M is the slope of the line, which we know is 1/2. X, if I look at the point they gave us, the x coordinate is 4, and b is the y-intercept, which is what I do not know. So now I'm going to multiply 1/2 times 4, that'd be 4 over 2, or just 2. And then we're going to subtract 2 from both sides, and that is going to tell us that b equals -1. So if I now combine the slope, which is 1/2, and the y-intercept, which is -1, that is going to give me the equation y equals 1/2 x minus 1, which will be the line that is parallel to 1/2 x plus 7, but it will pass through the point 4, 1. For example 3, it says determine which of the following lines are parallel to 2x minus 3y equals 21, explain why. Well, we know that parallel lines have the same slope, so if we can identify the slope of 2x minus 3y equals 21, that's our given equation, and then compare the slopes of the equations for A, B, and C, then we can determine which ones are parallel. So the equation that they gave us is not in slope-intercept form. So by looking at it, you cannot tell the slope. So we're going to have to rearrange it. So I'm going to do that work kind of down at the bottom. So 2x minus 3y equals 21. It should take 2 steps to rearrange. The first step is to move the x to the other side. So to do that, I need to subtract. So that's going to leave me with -3y equals 21 and -2x are not like terms, so don't put them together. You're going to have to write them side by side. Make sure you write the -2x first and then the constant at the end. Second step is to divide every term by -3 and simplify. So that would give us y equals -2 over -3 is a positive 2/3 x. And 21 divided by -3 is -7. So the slope of this line is 2/3. So now we need to go determine the slopes of the other 3 lines, and any of them that have a slope of 2/3 will be parallel. So if we look at A is in y equals mx plus b form. It's already in slope-intercept form, so we don't need to rearrange it. We just need to look at the equation and determine the slope, and the slope for A is -2/3. So since the slope for A is -2/3 and the slope that we have for our given equation is +2/3, these are not parallel. So it's not A. And there could be more than one answer for this. So, it could be B, it could be C, or it could be both B and C. All right, so B is in what we call standard form, just like the line they gave us originally. So we are going to have to rearrange it. Remember that it is 2 steps. Our first step is to move the x over, so we are going to add 6x to both sides. That's going to give us 9y equals +6x, and then put that constant at the end. Do not combine them. Write the x first, constant at the end. Then divide both sides, or everything, by 9, and simplify. 6 divided by 9 does simplify to 2/3, because if you divide both 6 and 9 by 3, you get 2/3x, plus 9 doesn't go evenly into 12, and that's okay. It's not a big deal. You can simplify it. 3 goes into each of those, so that would be 4/3. What we're looking at is the slope, and the slope of this line is 2/3. So it is the same as our given line. So B is definitely going to be parallel. Now let's look at C. C is also in standard form, so we're going to need to rearrange it. So we're going to move the 2x over by subtracting it. Got to do the opposite. That gives us 3y equals, write the -2x first and then the 7 last. Now divide everything by 3 and simplify when possible. -2/3 does not simplify. 7/3 does not simplify. So the slope of this line is -2/3, and that is not the same as the line that was given to us. So this is not parallel. So your only line that is parallel to the given line is line B. Now, if you compare A and C do have the same slope, so A and C would be parallel to one another. All right, now let's look at perpendicular lines. Again, we've talked about perpendicular lines in a lot of different aspects. We've talked about right angles and when things intersect and are perpendicular, 90 degrees. We applied that when we did circles. We applied that when we did perpendicular bisectors. We've done a lot with perpendicular, but now we're looking specifically at lines on the coordinate plane that are perpendicular. So when 2 lines are perpendicular on the coordinate plane, their slopes are opposite, reciprocal. So there are 2 things that have to be true. They have to have opposite signs. So one slope will be positive and one slope will be negative. The other thing is that the slopes are reciprocal. So if your slope is 1/2, the reciprocal of that would be 2/1, which is just 2. So an example of opposite reciprocal slopes would be 1/2 and -2, or -3/2 and +2/3. What's nice is that if you were to multiply the slopes of perpendicular lines, it always equals -1. So that's another way to look at it as well. All right, so for example 4, we are trying to decide if A, B, and CD are perpendicular. So similar to what we did with parallel, but now we're looking at perpendicular. So we are going to find the slopes of AB and CD and then compare them and see if they're opposite reciprocals. And if they are, then they're perpendicular, and if they're not, then they're not perpendicular. So watch your signs for AB. Remember, change in y over change in x. I'm going to look at the y values. It's 2 and 4. You can either do 2 minus 4 or 4 minus 2. I'm just going to do 4 minus 2. And then keep the consistency for the x values. So I need to do 5 minus 0. So that becomes 2 over 5, which does not simplify. Make sure you don't try to change that to a decimal. That could confuse you when you're trying to decide opposite reciprocals. Now let's look at CD. My y values for C and D are 8 and 3, so I'm going to do 8 minus 3, and in the exact same order, 1 minus 3 for the x values. So that's 5 over negative 2, which does not simplify. So now let's compare them. Are they opposites? Yes. One is positive, one is negative. Are they reciprocals? Yes. 2 over 5 got flipped to 5 over 2. So these are perpendicular. So perpendicular has opposite reciprocals, or if you want to look at it this way, if you multiply them together, you should get negative 1. So that would be 10 over negative 10, which would be negative 1. So it doesn't matter which way you like to think of it, whatever, makes more sense to you. Opposite reciprocals or the product is negative 1. For example 5, it says write the equation of the line perpendicular to y equals negative 2x plus 5, whose y-intercept is 12. So in order to write the equation, we need to know the slope and the y-intercept. Y equals mx plus b. They told us the y-intercept is 12, so we don't even need to solve for that. Our b is 12, so we can go ahead and put that in for b. What we need to do is figure out the slope. All right, so let's look at the line they gave us. It is in slope-intercept form, which means we already know the slope is negative 2. So the slope of the given line is negative 2. The slope of the perpendicular line should be the opposite reciprocal of that, which would be positive 1 over 2. So our slope would be 1 over 2. The y-intercept was given to be 12, so that would make the equation y equals 1/2 x plus 12. Okay, if you need to write, like the given slope was negative 2, if you need to write it as a fraction, negative 2 over 1, and then that helps you flip it, that's fine as well. All right, on number 6, write the equation of the line perpendicular to y equals 1/5 x minus 6, which passes through the point 1, negative 3. So similar type of equation to the one that similar type of problem to the one that we just did. We are trying to write the equation, so that means we need to know the slope and the y-intercept. All right, so for the equation they gave us, it's in slope-intercept form. They tell us that the slope is 1/5. So if the slope of the given line is 1/5, and we know that perpendicular has opposite reciprocal slopes, that would make the slope of the perpendicular line negative, because that's opposite, and then the reciprocal of 1 over 5 is 5 over 1, or just negative 5. So we've got our slope as negative 5. So now we need to figure out the y-intercept. They do not give us the y-intercept, but they do tell us it passes through the point 1, negative 3. 1 is an x value, and negative 3 is a y value. So we're going to use y equals mx plus b. We're going to plug in everything we know and solve for what we don't know. So y, the y coordinate they gave us, is negative 3. M was the slope of our line that we just figured out, negative 5. X is the x value they gave us, which is 1, and then we don't know b, that's what we're solving for. So I'm going to do negative 5 times 1, which is negative 5, and then I'm going to move that negative 5 to the left side to isolate b, and that's going to give me b equals positive 2. So the slope of the line perpendicular to 1/5 x minus 6 that passes through the point 1, negative 3 would be y equals negative 5x plus 2.